Hey everyone. Welcome back to another coding challenge. Today we're solving a classic problem that appears in coding interviews, converting Roman numerals to integers. We'll start by reviewing how Roman numerals work. Then we'll go through two different solutions. The first solution is going to be the brute force approach. And then the second one is going to be a little bit optimized. I'll code everything live so you can see my thought process line by line and discuss time and space complexity for each method. If you're ready, let's get started. And hey, if you enjoy structured coding breakdown, don't forget to like, comment, and subscribe. So let's do that. So the first thing we see here is, before we get a jump into the code, let's quickly review how Roman numerals work. Roman numeral consists of 7 symbols, and each with a fixed value. Generally, we add values from left to right. So for example, 2 ones will give you a 2, such as here. And 10 and 2 ones will give you, which is simply a 10 plus a 2. And the number 27 is written as 2 10s, a 5, and 2 2s. And here's how it's showing you how to split. And that gives you 27. These are the 7 symbol: 1, 5, 10, 50, 100, 500, and 1,000. I know these from memories from like elementary, kindergarten. These I'm not too familiar with. So instead of writing 4, which will be here, we write 4 this way. This applies in 6 cases. So for example, when we have 5, when we have 10, we'll obviously make 4 by having a 1 before the 5 and a 1 before the 9 will make 9. When we want to make 10, or when we want to make 40, we put a 10 before the L and a X before the C. This way they're subtracted and give us 40 and 90. Same thing for D. We put a C before it, a 500 becomes 400, and we put a C before M, 1,000 becomes 900. This means order matters. If a smaller number appears before a larger one, we subtract it instead of adding it. So now let's go to the problem statement. So given a Roman numeral, convert it to an integer. Here are the examples. Output, they give us an S, which is 111. They're added together to give us 3. S, the value is LV111, will convert to 58. Again, L is 50, the V is 5, and the 3 I's is 3. Added together, 58. Example 3, we got S. Now we got MCMXCI V. M equals 1,000. CM, since C, a smaller number before M. M being 1,000, C being 100. You subtract 100 from 1,000 gives us 900. Same thing happens here. X being 10 and C being 100. You subtract 10, it gives you 90. And here we already know that this is how you write 4. Now our constraint is the length of S will be a minimum of 1 and a maximum of 15 characters. S contain only these characters, as we saw at the top. And it is guaranteed that S is a valid Roman numeral in the range of 1 to 3,999. Now that we have a clear understanding, let's start coding. So first, I'm going to give you the brute force approach. And the first thing I want to do is I want to create a dictionary in order to capture all the Roman numerals as written here. So let me have it here for reference. So now that I coded up the Roman numeral, now we want to have total equals 0. This is where we're going to add up all the numbers. And n, which is the length, we're going to capture the length of the string s for the Roman numeral. And then we're going to do the brute force approach, which is we're going to go iterate through each index of the string. So here we're going to go all the way up to the length of n, but we're only going to check one digit before n in order to not go out of bound. And now we're going to compare the Roman integer where we index I so s being the Roman numeral and I being the index that we already have here will give us a Roman numeral. And then whatever that Roman numeral is, we're going to index it from the dictionary. So here, what we're doing is we already indexed the first digit in the Roman numeral in the string, and we found it here in the dictionary. We do the same thing here, and we look one ahead from the current string. So for example, if we were given, let's start using our example here. Let's say this, we're going to use this one just for the purpose of comparing what's happening here. So let's assume that we have, this one is 0. So let me copy and paste it. So if this is 0, then we know that at 0 is going to be L. Index 0 is going to be L. And then here, so this is going to be plus 1. So we got 0 plus 1, which is going to give us 1, index 1. So we're going to get this number. So what we're comparing here is L less than V? And again, L here is 50 and V is 5. So yes, 50 is greater, so this is going to return false. But nonetheless, if it was true, this is what we want to do in the event that it was true. We're going to subtract. So what we're going to do here is we're going to subtract the current index, which would be, if this was less than, we would subtract this from the total. But in this case, it doesn't apply since this number, 50, is greater than 5. So else, which is the situation that we have now, we're going to get the total, and what we're going to have is we're going to add that Roman numeral. So let me just copy and paste it from here. So we got the second Roman numeral, which is going to be 5. We're going to add it to 50, so it can give us 55. And then when everything's done, we're going to return the total. So going through this specific example, as mentioned here, we're going to get 50 when we first get L. Then we're going to get 5. So let's say we are here. We got 50. Is it less than 5? The answer is no. first here we're checking if we're at the end of the index. We're not. So now we want to make sure both are true, which in this case we're saying is index 0, which is 50 right here, less than the Roman index of 5. The answer is false. We're going to get the number, since it's going to be false, then we're just going to skip this because we got true and then we got false. So they both have to be true in order for us to execute this. Since this is true, this is false, we're not going to be able to execute it. So we're going to compare this code, which is going to be, well, we're going to add it. We're going to add 50 to 5, and we're going to get 55. And then we're going to go again, and we got 55, and then we're going to get 1, then we're going to add another one, which will give us 58. And that's how this code works. When we finish this code, what we're going to have is, because there's one loop, the time complexity is order n. And because there is no added space, we're just maintaining this, the way it is, the space complexity is order n as well. And in this case, since we're using a dictionary to search up items, the time complexity is order 1, because that's how fast it is to search for any value based on this indexing. So now let's try so this one right here, this method works, but it's not the most efficient. The method I'm going to show you is better, but it has the same efficiency. It's just another way of doing it with less code. So we explicitly checked for subtractive cases here, making the code a bit longer than necessary. So let's optimize it. But before I do that, let me just see the solution and if it passes the test. So let's see if I made an error. So here I got n-1. Let's see what the error is. What it's saying, name error global Roman to int. So my name is not properly formatted here. Roman to int, solution Roman to int. Okay. So I think that's where the error is. Let's run it again. Okay, so let's see where the error is coming. Roman to int. Let's see what I name it. Roman to int. Let me just copy it just to make sure. So Roman to int, which is here. Okay, so I think the error is this. Not being closed, Roman to int. And maybe here I got 2 of them. Might be the problem. Okay, so let's run it again. Okay, Roman to int. I misspelled this. And this should be good. Okay, so let's see what else is the error here. Roman to int is properly spelled. SI+1. Oh, and let's see. It looks like it's correct. So I got I here. Okay. So I should probably take out that +1 here. Because at the end of the day, all I'm doing is adding my current value regardless. So the issue that runs here is in the event that we are out of bound in the out statement. And by just putting the current value, at the end of the day, we're not going to be out of bound. So as you can see, the value is 3 and we got the expected output. Same thing for case 2 and same thing for case 3. So now let's see what our runtime is. So based on this, it takes 5 milliseconds. It is better than 82% of people that have submitted this problem before. So now let's try the optimized solution. And let me take this out. So here, what I'm going to do is I'm going to do the previous value instead equals 0, and then for char in reversed s. So now here we're going to look at the Roman numeral that we are given. Let's say again, we're going to try this. Okay, let me copy again. So looking at this, we're reversing the string. So char is going to start from the right to left. The previous one started from left to right. Now we're going to start from right to left. So the current value equals Roman to int, and it's going to be the chart. So here Roman to int is our dictionary, and we're going to initialize it with our current value, our current chart, which will give us the actual number here. We're indexing this side, and it's going to return this number. Now if the current value is less than the previous value, now we got total is going to be minus equal to the current value. Else total is going to be plus equal the current value. And in the event that neither case is true, then we're going to get previous value equals current value, and then we're going to return total. So just to explain the code here, so here we're going to get the value, we're going to assign it to current value. So let me fix this. Then what we're going to do in comparison to this, let's see if we have any. Let's start with this instead, since this already is never going to show the first case. So let's do this one instead. And let's use the explanation as is written here. So we're going to assign the current value, which the first one, instead of going this route, we're going to go from this route. So what we have here is the current value, which is 5. It's going to show up, 5 being the first digit here. And previous value is already initiated to 0. So if current value, which in this case is 5, is less than 0, this is going to return true. So we got 5 is going to be, 5 is not less than 0. 5 is greater than 0. So because that's the case, we're going to add 5 to total. So it's going to give us 5. And since that's the case, current value is going to be equal, total is going to equal 5. And here we still got current value, which is going to be 5, and previous value is going to be given the number 5. Now we go again here, and now we're looking at the next value here, which would be here, and that's going to be 1. So 1 is going to be assigned to current value. Now we're going to compare current value. Is it less than previous value, which is 5? In this case, it is true. So the reason we're doing this is because now, instead of doing the subtraction, which we were doing before, by doing the 1,000, and we're subtracting here with 1,000 minus 100 to get 900, we're not doing that anymore. All we're doing is we're handling it here. So now we're going to subtract 1 from the total. The total is currently 5, and when you subtract 1, it's going to be 4. So again, we got the current value at 1. Previous value is going to be equal to 1. We're going to initialize it. So then we're going to go again here. Now we're going to go to the next one. And in this case, now we're going to C. C being 1,000. So we got 1,000. Current value is currently 1,000. Current value, is it less than previous value, which was 1? The answer is no, it's false. So then we're going to add 1,000 to what we already have of 4. So we got 1,004, or 104 actually. So it's going to be 104. And then we assign 100 to previous value. So then we go back again here, and we're going to go and see here. So we're going to assign 10 to current value. Is 10 less than 100? The answer is yes. That being the case, current value is going to be subtracted from total. Total is 104. So we're going to subtract 10. So that's going to give us 94, which is what we have here so far, 94. Then 10 is going to be added to previous value. We're going to go back again here because the loop, and we still have not ran out of strings. So we got the next value, which is going to be, let's go to M. So M is 1,000. It's going to be given to current value. Current value is less than, is it less than previous value, which is 10? The answer is no. So we're going to go here and we're going to add it. And this is going to continue all the way until we finish this string. And eventually we're going to get the answer of 1,094. And as you can see, this is a little bit more optimized, but at the end, the answer is still going to be order n. And the reason for that is because we only have one for loop. Our search is still going to be order 1 because we're still using a dictionary, and that's how fast it takes to find a value. And this approach just simplifies the logic and runs in order n time and O1 space. So both approaches run in O1 time, but the optimized version is cleaner and more efficient. And let's see if there's any errors in my code. Okay, so let's see, Roman to int. That should fix it. Okay, again, all 3 give me the go ahead. And now let's see how well I did compared to others. Okay, so still 4 milliseconds, so it's just as fast, and it beats 88% of people that have done it. And there you have it. We explored 2 approaches to convert Roman numerals to integer. If you found this helpful, like, comment, and subscribe for more coding tutorial. I'll see you next time.